Hello everyone, today we will obtain an equation of motion for a system which is having two masses m1 and m2, and these two masses are connected by an inextensible string of length L, and this string is moving on a massless pulley. Let us consider that the length of this string is L and the mass m1 has the variable vertical distance x from the pulley, so the mass m2 will have the variable L minus x distance from the massless pulley. As you know that the Lagrangian for such a system can be defined as L is equal to T minus V. Here L is Lagrangian, T is kinetic energy and V is potential energy. Let us say it is equation number 1. Now as the two masses move, so we can find their velocities. Let us say the velocity of the mass m1 is defined as v1, so it will be equal to d over dt x, and we can write it as x dot. Similarly, the velocity of the mass m2 will be v2, and it is equal to d over dt L minus x, and it will be equal to minus x dot. Let us say it is equation number 2 and it is equation number 3. Now the kinetic energy of the system will be 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. Because the mass of the pulley is negligible, so we have not considered its rotational kinetic energy. So it will be 1 by 2 m1 x dot square plus 1 by 2 m2. As you know that v2 is equal to minus x dot, so it will be minus x dot whole square. So kinetic energy of the system is given by equation number 4, and it is equal to 1 by 2 m1 plus m2 x dot square. Now we will calculate the potential energy of the system. As in our earlier example, if we consider pulley as a reference line, then above the pulley the potential energy will be considered positive, and below the pulley potential energy will be considered negative. So it will be V is equal to minus m1g x for m1 mass and plus minus m2g L minus x for m2 mass, and let us say it is equation number 5. So we will put the equation 4 and 5, find the value of the Lagrangian. As you know that L is equal to T minus V, so your T is given by equation number 4 and V is given by equation number 5. So your L now become as 1 by 2 m1 plus m2 x dot square plus m1g x plus m2g L minus x, and let us say it is equation number 6. As you know that here x is a variable, so it will be considered as a generalized coordinate. So Lagrangian equation for when x is the generalized coordinate, it can be written as d over dt del L over del x dot minus del L over del x equal to 0, and let us say it is equation number 7. Now from equation number 6 we will find the value of del L over del x dot, and it is equal to m1 plus m2 x dot. Let us say it is equation number 8. Then we will find del L over del x, it is equal to m1 minus m2 g. Let us say it is equation number 9. Now we will put equation 8 and 9 in equation number 7. So we find that the x double dot, this is the constant acceleration of the system, and it is equal to m1 minus m2 g upon m1 plus m2. Here if m1 is greater than m2, then m1 will move in the downward direction and m2 will move in the upward direction. If m2 is greater than m1, then m2 will move in the downward direction and m1 will move in the upward direction. Thank you.